Hey guys, welcome back. Mr. Larson here. Today we're talking 4.3, which is right angle trigonometry. Right angle trig, anytime we have right triangles, that pulls a couple things into play. SOHCAHTOA is our trig that we're going to use. So we'll review that and talk about some of the reciprocal trig functions as well. Right triangles also opens up Pythagorean theorem. So I don't tell a lot of people this, but I was in a band, real heavy metal band back in high school, named the Pythagorean theorem. It was pretty killer. I played the triangle, so haven't done it in a while, but maybe I'll dust off the old records soon. Okay, so first thing we're going to talk about is using the calculator, which we haven't done really. We've been finding exact values. So if we look at 1 and 2 here, we're going to use the calculator for approximate values, meaning we're going to get a decimal, we're going to have to cut it at some point, right? Sometimes these also end up being exact, like if it's not a repeating decimal, but main thing to do here is check your mode on the calculator. If you are supposed to be in degree mode, be in degree mode. Same thing for radian. So that's where a lot of the mistakes happen. So if we go to mode, this number 1 sign of 0.8, there's no degree symbol, so that's going to be radian. So it looks like third option, yeah, I'm already in radian mode. So all we need to do is hit sine of 0.8, and we get 0.717. Let's go 3 spots after the decimal. Okay, now we need to switch to degree and cosecant. So we'll review the reciprocal functions later in the notes, but cosecant is the reciprocal of sine. Okay, so there's no cosecant button. The way we figure out that value is do 1 over sine. Okay, so 1 divided by sine of 22.8 degrees. Okay, so 2.581. Okay, easy as that. So this note up here, don't do inverse sine. Make sure you're doing 1 divided by sine. Inverse sine is something different that we'll cover at another time. So here's an example. If we look at 1, 2, and 3, so this is telling us either some information about the triangle or a trig value of a triangle. We need to try to piece in some other information. So ideally, if you can find all 3 side lengths, then you can find all 6 of your trig functions. Okay, so let's call this side right here x. I can use Pythagorean theorem, because this is a right triangle, to find that leg x. Okay, so x squared plus 16 is 36. Meaning x squared is going to be 20 after I subtract 16. We don't need plus or minus because we're talking about side lengths. It's always going to be positive here. So x is going to equal positive root 20. Or I can split that up to root of 4 times root of 5, which is 2 times root 5. All right, so sine, cosine, and tangent should be pretty straightforward. SOHCAHTOA. So I need to fill in. Let's see. Here's my theta. So opposite, adjacent, and hypotenuse. Sine is opposite over hypotenuse. I'll reduce and get 2/3. Cosine is adjacent over hypotenuse, so 2 times root 5 over 6, reduce. Tangent, opposite over adjacent, so 4 over 2 root 5. 4 over 2 is going to reduce to 2 over 1. And then I still have root 5 on the bottom. And then remember, we learned how to rationalize. So I want to get rid of that root 5, so I multiply it by root 5 over itself. and we get 2 times root 5 over 5. Okay, so remember sine has a reciprocal function which is cosecant. So cosecant of theta, take sine, flip it on its head. Secant is going to be the reciprocal of cosine, so take the cosine value, flip it on its head, and then you have to rationalize. I like to rationalize in green apparently. So that gives me 3 root 5 over 5. And then last but not least, cotangent, reciprocal of tangent. So I could take this final answer for tangent and take the reciprocal. Of course, that's going to put 2 root 5 on the denominator. So what I'm actually going to do is look back. This is also a value of tangent. And when I take the reciprocal of that, I don't have to worry about rationalizing because that root of 5 goes to the top, right? So just kind of be smart about that. You can save yourself some time. If you took this value, took the reciprocal, and then rationalized, after you reduced, you'd get the same as what we just got. But sometimes if you kind of look for the right value that has a root on the not on the top, by the time you flip it, it won't have a root on the bottom. Okay. All right, sine of theta equals 5 over 13. Well, let's draw a triangle first on number 2. Right triangle. This is going to be opposite over hypotenuse. So the hypotenuse is 13. I should designate theta. Let's say this angle here is theta. So opposite from there is this vertical side. And there's some Pythagorean triples. Hopefully you guys know some of these. Pythagorean triples means that 3 numbers like a 3, 4, 5 is a set of numbers such that if you had a right triangle and a leg was 3 and another leg was 4, Pythagorean theorem would calculate that the hypotenuse would be 5. And you're free to check that. That works. Another one is 5, 12, 13. So 5 squared plus 12 squared equals 13 squared. Knowing that, I know that this bottom side is going to be 12. If you don't know that, don't stress. You can just use Pythagorean theorem like we did on number 1. Okay, but the 3 triples, Pythagorean triples that will benefit you the most are 3, 4, 5, 5, 12, 13, and 8, 15, 17. So if you see 2 of those sides, you should be able to know what the other one is. Just make sure that this biggest one is the one that you always plug in as the hypotenuse. Okay, so once we have that, this should be pretty quick, right? I know sine, I'm not going to write that again. Cosine, let's see, this is hypotenuse, opposite, adjacent. Tangent 5 over 12. Secant, cotangent, and then I didn't do cosecant, which will be the reciprocal of what was given, right? Reciprocal of sine. So there's your other 5, and there's the first one. Okay, secant of theta equals 3. I like to always think of sine, cosine, and tangent. Those are the 3 that I'm most familiar with. So if secant is equal to 3, we know that cosine is equal to 1 over 3. So again, you can sketch a triangle. Let's pick one of the non-right angles as theta. Cosine is adjacent over hypotenuse. So I know that this is my adjacent, hypotenuse, opposite. Let's fill some lengths in. Pythagorean theorem. 3 squared is 9. X is root 8, which comes out to 2 root 2. And then you can fill out your, I'll let you guys finish that one up, but you can fill everything in from there. So you need 4 more trig values since you already kind of have 2 over here. Okay, for number 4, let's see, find x. Find x. There it is, right? Okay, so what I want to do is, here's theta, here's the angle we're talking about. What information do I know? I know the opposite, and what I'm looking for is adjacent. So it's a right triangle, so I can use sine, I can use SOHCAHTOA. So tangent is the angle, or is the function that uses opposite and adjacent. So 32 over x. Let's put this over 1. Cross multiplying, I get 32 equals x times tangent of 60 degrees. And we can plug that in the calculator. Make sure you're in degree mode. I am from last time. And we get 18.475. All right, guys, feel free to pause to get these written down, but reciprocal identities, we talked about sine and cosecant partner together, cosine and secant, and then tangent and cotangent. Some people struggle to remember which ones pair up, for the reciprocal identities. I think tangent and cotangent is the one that everyone tends to remember, tangent, cotangent. And then remember the other 2, every pair has one function that starts with the letter C. So cosine won't go with cosecant, right? Because those both start with C. But secant is the other one that's left, and then sine would go with cosecant. So everyone has one that starts with the letter C. That's how I remember it. Quotient identities, quotient meaning division, right? So tangent is equal to sine over cosine, or sine divided by cosine, right? Cotangent is the reciprocal of that. It's cosine divided by sine. And then feel free to write these Pythagorean identities down. I don't know that we use these a ton in this chapter, but we will once we get to chapter 5 a lot. And we'll show you how to remember those, and how we can, after knowing the first one, how we can derive the second and third one. So please get those written down, and then unpause when you're ready. Okay, guys, for this last part, all we're doing is providing you with the trig value, so either the sine, tangent, cotangent, whatever the value is. Theta typically represents an angle, so you don't know the angle. So your job here is using the information of a trig value. Can you tell us where that's located, what angle that's located? So all this means is it's in the first quadrant, right, between 0 and 90 degrees, or between 0 and pi over 2, which is also 0 degrees and 90 degrees. This also means I want this answer in degrees and radian. So if one of your answers is 45 degrees, you would also tell me pi over 4, because that's the radian equivalent. Okay, so I told my class that we're going to know the first quadrant really good, and then use that to find information about quadrants 2, 3, and 4. So what I did on this is I just sketched quadrant 1, the degree measures in black, radians in gray, coordinates in green. And just a reminder here, the coordinates represent your cosine comma sine, and then to find tangent, you do your y coordinate over the x coordinate. So everything we need is right here, and I'll show you how we can use that. Okay, so sine of theta equals 1/2. Well, that's pretty easy, right? Sine is just listed as the y value. Find in quadrant 1 where it's 1/2, and that would be at 30 degrees, right? So this is 30 degrees. Also, that would be pi over 6. Okay, so give it to me in both ways. If you forget it's pi over 6, you can convert by multiplying by pi over 180. Okay, tangent. This is a tricky one. Tangent of theta equals square root of 3. Here's what I want to do. let's find the tangent values of all of these angles, okay? I'm going to do 0 and 90 first because those are real quick. So tangent here is y over x, so 0 over 1. Tangent equals 0 over 1, which is 0, okay? Let's do 90. Tangent equals 1 over 0, which is undefined. Okay, undefined up at 90. Next, let's do 45. Root 2 over itself. I'm sorry, root 2 over 2 over itself. Well, that's going to equal 1, right? Dividing something by itself. So 0, 45, and 90 are pretty easy. A lot of people just memorize those, but you should be able to calculate them in just a couple seconds. So this is saying tangent is equal to square root of 3. Well, there's only two options left. It's either 30 degrees or it's 60 degrees, right? Clearly it's not 0, 90, and 45. So how can we use that to our advantage? Well, if I know it's one of those two, check one of them, and if it comes out to be root 3, then you got it. If it's something other than root 3, then it must be the other one, and you can verify that if you need to. So let's see, I'm going to check 30 degrees. Let's just check the tangent of 30 degrees over here. So tangent of 30 is going to be my y over my x. Well, instead of dividing by that fraction, we'll do 1 over 2 times the reciprocal, right? 2's are gone. 1 over root 3. I need to rationalize. Which is going to give me root 3. Ooh, that's root 3 over 3. Okay, so tangent of 30 is not root 3. It's root 3 over 3. Okay, let's just check 60 real quick. So tangent at 60 root 3 over 2 times 2 over 1. 2's are gone. There we go. I'm left with root 3 over 1. So it is root 3. Okay, so that is 60 degrees, also known as pi over 3 in radians. All right. Cotangent of theta is equal to 1. So this is interesting. A couple ways to think about this. We know that tangent of x is y over x. Tangent of theta is y over x. We could also think of cotangent would then be x over y, right? So I'm not going to go do all the cotangent values for quadrant 1 because I don't think it's necessary, but you could just go look at your x over your y and look at where that ratio would be equal to 1. Okay, some of you guys are probably already realizing where that's going to be. What I like to do is kind of the opposite approach and think, okay, I know sine and cosine are found amongst the coordinates, the x and y coordinates, and tangent's the other one that I'm really comfortable with. We've already found all of the tangent values, right? So this is 1 over 1. I'm going to also use this information. If cotangent's 1, tangent is the reciprocal of 1. Oh, that's also 1 actually. Okay, so now I'm going to think about tangent equaling 1. It's going to be the same angle as if I thought of cotangent equaling 1. So we already did this work. We know that when the x and y are the same, that's when I get a ratio of 1. So that's going to be 45 degrees or pi over 4. Okay. And then secant, again, secant doesn't show up on the unit circle, but secant is the reciprocal of cosine. Cosine shows up, so I'm going to use this information. Cosine of theta is the reciprocal of secant. Now, I don't see 1 over root 2 anywhere on the unit circle for a coordinate, right? Oh, I didn't rationalize. Okay, so let's rationalize, which is going to give me root 2 over 2. Okay, that's a little easier. cosine represents my x value. Where's my x value? Root 2 over 2. I see it right there at 45 degrees. Pi over 4. Okay, so I hope that helps you. Tried to talk you through a couple tricks and a couple pieces of strategy. You're going to get a lot more practice with this, especially on the practice today and with the homework. So thanks for tuning in, guys. Appreciate it.